let's discuss magnetic properties of materials. Okay, in this magnetic properties of materials, we have to classify the materials in three types. One is the diamagnetic materials, paramagnetic materials, and ferromagnetic materials. These materials are classified based on some magnetic parameters. The most important magnetic parameters are susceptibility and permeability. So the susceptibility is denoted as psi and mu is the permeability. So already we discussed about the susceptibility and permeability. So the susceptibility, you know that generally it is the degree of magnetization. A material, how much it should be magnetized after removal of the external magnetic field. That one you have to call it as susceptibility. And mu is the conductivity of the magnetic field lines, or so the number of field lines passes through a material is called permeability. So based on the susceptibility and permeability, we have to classify these three types. So now we have to discuss one by one. So what are the diamagnetic materials, paramagnetic materials, and ferromagnetic materials? So first we have to discuss about diamagnetic. The first point is these materials to move from stronger to weaker part of the external magnetic field. So if you take a external magnetic field, okay, when you take a material, diamagnetic material, near to this external magnetic field, at that time this material will be repelled by this external magnetic field. It means this is the strongest magnetic field, so it will be repelled by this magnetic field lines. When it will be repelled, at that time it will be moved from stronger magnetic field to the weaker magnetic field. Okay, these are the diamagnetic materials. So for example, so the copper, gold, silver, lead, Hg, and water, these are the examples for the diamagnetic materials. Okay, and next, when a bar of a diamagnetic material placed in an external magnetic field, the field lines are repelled by material. So if you take a magnetic field lines, so you have to put a magnetic field lines inside this magnetic field. So at that time the magnetic field lines are repelled by this material. Okay, I shown here. Okay, the magnetic field lines are repelled by the material. Okay, when you take a bar magnet inside the external magnetic field lines, at that time it will be repelled. Andre ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ನ ಒಂದು ಫೀಲ್ಡ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಒಳಗಿಟ್ಟಾಗ ಇವು ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಲ್ಲ ಏನಾಗ್ತಾವೆ, ರಿಫೆಲ್ ಆಗ್ತಾವೆ. ಓಕೆ, ಇನ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕಂಡೀಷನ್ಸ್. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಥರ್ಡ್ ಒನ್ ಈಸ್ placed. The bar magnet is placed in a non-uniform magnetic field. It tends to move away from the magnet. It means it moves from stronger to weaker. Other here we kept a magnet in uniform magnetic field. Also you have to kept this magnet in a magnet non-uniform magnetic field. Magnetic field lines are, they will be randomly moved. So when you kept a diamagnetic material inside this non-uniform magnetic field, at that time also it will be repelled and it will be move a weaker magnetic field to the stronger magnetic field to the weaker magnetic field. It moves from stronger to weaker. So magnetic dipole moment of the atom is 0. Okay, if you the magnetic dipole moment of atoms in the 0. In the diamagnetic materials, you have to, in the diamagnetic materials, so the magnetic dipole moment of the atoms will be 0. They should not move. in the atoms should not move in the diamagnetic materials. So the dipole moment of the atoms is 0 in the diamagnetic. The magnetic susceptibility has a small negative value because the diamagnetic materials are refilled. So at that time the magnetic susceptibility has a small negative value. It cannot show a first value because the diamagnetic materials, it does not magnetize. That's why if the material is magnetized, at that time the susceptibility will be positive. Here it does not magnetize, that's why it is having a small negative value. And next, the relative permeability slightly less than 1. Okay, so the relative permeability of the diamagnetic material is less than 1 because it does not permit any magnetic field lines inside, or it will be permit only a very less number of magnetic field lines. That's why you have to consider its value is less than 1. And mu is the permeability. So the permeability of the material is less than mu naught, the permeability of vacuum. So the permeability of diamagnetic materials is less than permeability of vacuum. So vacuum ದಾಗ ಎಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಪಾಸ್ ಆಗ್ತಾವಲ್ಲ ಅಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನು ಈ ಮಟೀರಿಯಲ್ ಒಳಗೆ ಪಾಸ್ ಆಗಿಬಿಡೋದಿಲ್ಲ, ಅದಕ್ಕೆ ಇದಕ್ಕಿಂತನೂ ಇದು ಲೆಸ್ ಐತಿ. ನೆಕ್ಸ್ಟ್, at very low temperature diamagnetic materials exhibits superconductivity. Okay, when you reduce to very small temperature, at that time the diamagnetic materials act as a superconductor. So superconductors having the -1 susceptibility and relative permeability having 0. So the superconductors are nothing but the phenomena of perfect diamagnetism in the superconductor is called Meissner effect. Okay, and it obeys the Meissner effect. It means when you take a diamagnetic material inside a external magnetic field, at that time the magnetic field lines are repelled by this diamagnetic material. That is the Meissner effect. And the diamagnetic materials are exhibits a superconductivity at a very low temperature. And this is all about the diamagnetic materials. And next we have to discuss about the ferromagnetic materials. And in this ferromagnetic materials, so we got these materials to move from weak magnetic field to strong magnetic field. Okay, when you take a ferromagnetic materials near to the magnetic field, at that time it will be moved from weaker to stronger, means it will be attracted by the magnetic field lines. So it will be attracted by the magnetic field lines, so it is having weakly magnetized in external field. So external field ಒಳಗಿಟ್ಟಾಗ it will be weakly magnetized. This material is weakly magnetized. ಅಂದರೆ ಈ ಮೆಟೀರಿಯಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿನ ಪಡ್ಕೋತೈತಿ ಯಾವಾಗ ನೀವು ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನಾಗ ಇಟ್ಟಾಗ. ಸೊ ಅಂಥ ಮೆಟೀರಿಯಲ್ಸ್ ಯಾವ ವೀಕ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿಯನ್ನು ಪಡ್ಕೊಳ್ಳೋ. ಸೊ ವೀಕ್ಲಿ ಯಾವ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಅಥವಾ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಗ್ತಾವಲ್ಲ ಆ ಮೆಟೀರಿಯಲ್ಸ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅಂತೀವಿ. So example for these materials is aluminum, sodium, calcium, oxygen, tungsten. So when a bar of a magnetic material placed in an external magnetic field, the field line gets concentrated inside the material. Inside the material field lines, the material slightly increase. Here, when you put a paramagnetic materials inside a external magnetic field, at that time, so the magnetic field lines are concentrated inside the material. So in the diamagnetic the materials are repelled, but in the ferromagnetic they will be concentrated inside the material. That's why the material will be slightly magnetized. Okay, and this is the second part. And next, in non-uniform magnetic field, it tends to move weaker to stronger region. So ಅಲ್ಲಿ non-uniform magnetic field daga diamagnetic ಒಳಗೆ it will be move stronger to weaker region because it will be repelled. But in non-uniform magnetic field of ferromagnetic materials, it will be move weaker to stronger region. ಅಂದ್ರೆ weak magnetic field ಇಂದ strong magnetic field. ಅಂದರೆ weak magnetic field ಇಂದ strong magnetic field ಅಂದರೆ it will be attracted by the external magnetic field lines. Okay, and next one is these materials possesses a small value of permanent magnetic dipole moment. ಇವು ಮೆಟೀರಿಯಲ್ಸ್ ಏನು ಮಾಡ್ತಾವೆ ಅಂದ್ರೆ ಪರ್ಮನೆಂಟ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತಾವೆ. ಓಕೆ, ಸೊ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ಸ್ ತೊಗೊಂಡ್ರೆ ಅಂದರೆ ಇದ್ರೊಳಗೆ moment of electrons ಇರ್ತಾವೆ. These moment of electrons will be permanently magnetized. When the material will be magnetized, at that time these dipole moments will be moved in the direction of external magnetic field. The material possesses a small value of ferromagnetic dipole. Next, the magnetic susceptibility has a small positive value. ಇಲ್ಲಿ ಯಾಕೆ ಸ್ಮಾಲ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ಬರ್ತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ವೀಕ್ಲಿ ಮ್ಯಾಗ್ನೆಟೈಸ್ಡ್. ಅಂದ್ರೆ ಇದ್ರೊಳಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ನ ಅದ್ರೊಳಗೆ ಹರಿದು ಬಿಡಾಕ್ಬಿಡ್ತು. ಸೊ ಇಲ್ಲಿ ಪರ್ಮಿಯಬಿಲಿಟಿನೂ ಪಾಸಿಟಿವ್ ಆಯ್ತು ಆ್ಯಂಡ್ ಸಸೆಪ್ಟಿಬಿಲಿಟಿನೂ ಪಾಸಿಟಿವ್ ಆಯ್ತು. ಯಾಕಂದರೆ ಈ ಮೆಟೀರಿಯಲ್ ಇಲ್ಲ ಇದು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ಸ್ ಒಳಗೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ ಹಾದು ಹೊಂಟವು. ಸೊ ಅದಕ್ಕೆ ಇಟ್ ವಿಲ್ ಬಿ ಇದು ಪರ್ಮಿಟು ಮಾಡಿತ್ತು. ಅಂದ್ರೆ ಪರ್ಮಿಯಬಿಲಿಟಿನೂ ಪಾಸಿಟಿವ್ ಆಯಿತು, ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ನಿಯರ್ ಟು ದಿ 1 ಆಯಿತು. ಆ್ಯಂಡ್ ಸಸೆಪ್ಟಿಬಿಲಿಟಿ ಅಂದ್ರೆ ಇದರೊಳಗೆ ಫೀಲ್ಡ್ ಲೈನ್ ಹಾಕೋದಾಗ ಈ ಮೆಟೀರಿಯಲ್ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆಯಿತು. ಸೊ ಮ್ಯಾಗ್ನೆಟೈಸ್ ಆದಾಗ ಇಟ್ ವಿಲ್ ಬಿ ಸ್ಮಾಲ್ ಪಾಸಿಟಿವ್ ಸಸೆಪ್ಟಿಬಿಲಿಟಿ. ಇಟ್ ಶೋಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಸಸೆಪ್ಟಿಬಿಲಿಟಿ ಹ್ಯಾಸ್ ಎ ಸ್ಮಾಲ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ. ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ರಿಲೇಟಿವ್ ಪರ್ಮಿಯಬಿಲಿಟಿ ಸ್ಲೈಟ್ಲಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1. So I already told the permeability is also greater than 1, and here mu is slightly greater than the mu naught. The mu andre permeability. So permeability of paramagnetic materials. So permeability of paramagnetic materials is greater than the permeability of vacuum. So mu naught is the permeability of the vacuum, and the susceptibility of ferromagnetic materials inversely proportional to the absolute temperature. So the susceptibility of ferromagnetic materials is inversely proportional to temperature. So if you have to increase the temperature, of the diamagnetic materials, at that time susceptibility goes on decreasing. And if you decreasing the temperature, at that time susceptibility goes on increasing. Okay, this law you have to call it as a Curie temperature. Temperature ka ಏನಂತೀರಿ Curie temperature ಅಂತ ಹೇಳ್ಕೈತೆ. So this here I written here the susceptibility is directly proportional to the 1 by T, and x equal to C by T. C here you have to take it as a Curie constant. It will be constant, and this is known as a Curie temperature. So the magnetic field increased or a temperature decreases. Magnetic field increase atandra temperature decreases till magnetization values saturation value of Ms. ಸೊ ಎಲ್ಲಿ ತನಕ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ವ್ಯಾಲ್ಯೂ ಸ್ಯಾಚುರೇಷನ್ ಲೆವೆಲ್ ರೀಚ್ ಆಗ್ತದೆ. ಸೊ ಇಲ್ಲಿ ಇಫ್ ಸಸೆಬಿಲಿಟಿ ವರ್ಸಸ್ ಟೆಂಪ್ರೇಚರ್ ಗ್ರಾಫ್ ಹಾಕಿದಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ಕ್ರೀಸಸ್ at a saturation level. After that it will be constant. After this point is you have to take it as a saturation level. This is about the paramagnetic materials. So the paramagnetic materials having a small ferromagnet dipole moment, it is having a small positive value, and these materials will be moved from weaker region to stronger region, and the permeability of this material have slightly greater than 1. here ferromagnetic materials. These ferromagnetic materials are completely magnetized materials. These materials will be more stronger magnetic field when magnetized when placed in an external magnetic field. It moves from region of weak magnetic field to strong magnetic field. So the same as per ferromagnetic we discussed. When you put it is in external magnetic field, and it will be move from stronger magnetic field to the weaker magnetic field. Weaker magnetic field to the stronger magnetic field. So here it moves region of weak magnetic field to strong magnetic field. They strongly attracted by magnets, and these are strongly attracted by magnets. Example for this is iron, cobalt, nickel. So before going to the discuss further points, first you have to discuss about the ferromagnetic domains. So what mean by domains? Domains are nothing but a group of atoms present in the ferromagnetic material. If you consider one material here, this is the ferromagnetic materials. So the group of atoms are present. This one group, this one group, this one group, and the group of atoms direction. The group of atoms aligned in the same direction, but each domain. This domain, this one is domain separate. This one is domain separate. Each domain having a different directions. This group of atoms will be one direction. This group of atom will be one direction. This group of atom will be one direction. But each domain, each group having a different directions. So when you take this material inside the external magnetic field, you have to take this material inside the external magnetic field. At that time, these domains will be move in a same directions. All domains will be takes a moment in the direction of external magnetic field. ಇವು ಎಲ್ಲ ಡೊಮೇನ್ಸ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಇರ್ತಲ್ಲ ಆ ಡೈರೆಕ್ಷನ್ದಾಗ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಓಕೆ, ಹಿಂಗೆ ಚೇಂಜ್ ಆಗೋದ್ರಿಂದ ಈ ಮಟೀರಿಯಲ್ ಈಸಿಲಿ ವೀಕ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡಿಂದ ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕಡೆ ಮೂವ್ ಆಗ್ತೈತಿ. ಅಂದರೆ ಇಟ್ ವಿಲ್ ಬಿ ಅಟ್ರಾಕ್ಟೆಡ್ very easily. And the next concept is when a bar of ferromagnetic material is placed in an external magnetic field, the field lines highly concentrated inside the materials. Okay, ನೀವು ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ದಾಗ ಈ ಮಟೀರಿಯಲ್ನ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನಾಗ ಇಟ್ಟರಂದ್ರೆ ದ ಆಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಸ್ ಆ್ಯಂಡ್ ಲೈನ್ಸ್ ಆರ್ ಈಸಿಲಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಇನ್ಸೈಡ್ ದಿಸ್ ಮೆಟೀರಿಯಲ್. ಅಂದರೆ ಈಸಿಲಿ ಎಲ್ಲ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇದ್ರೊಳಗೆ ಪಾಸ್ ಆಗ್ತಾವೆ. ಸೊ ಎಲ್ಲ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಲ್ಲನೂ ಪಾಸ್ ಆಗೋದ್ರಿಂದ ಇಟ್ ಮೆಟೀರಿಯಲ್ ಬಿಕಮ್ ಹೈಲಿ ಮ್ಯಾಗ್ನೆಟೈಸ್ಡ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇಫ್ ಯು ಕೆಫ್ಟ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫಾರ್ ಇನ್ ಎ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ and it will be moved from weaker magnetic field to the stronger magnetic field. And the next point is the ferromagnetic materials are classified into two types. Okay, one is the hard ferromagnets and another one is the weak soft ferromagnets. Hard ferromagnets, when you remove the external magnetic field, at that time the material persist magnetization. ಅಂದ್ರೆ ಹಾರ್ಡ್ ಮೆಟೀರಿಯಲ್ಸ್ ಏನಿರ್ತಾವಲ್ಲ, ಆಫ್ಟರ್ ರಿಮೂವಲ್ ಆಫ್ ದಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ದೇ ಶೋಸ್ ದ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಪ್ರಾಪರ್ಟಿ. ಇಟ್ ಮೀನ್ಸ್ ದೇ ಕನ್ವರ್ಟ್ ಆ್ಯಸ್ ಎ ಮ್ಯಾಗ್ನೆಟ್. ಸೊ ಆ ಮೆಟೀರಿಯಲ್ಸ್ಗೆ ಏನಂತ ಕರಿತೀವಿ? ಹಾರ್ಡ್ ಫೆರೋಮ್ಯಾಗ್ನೆಟ್ಸ್. ಸಾಫ್ಟ್ ಫೆರೋಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅಂದರೆ ದ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಡಿಸಪಿಯರ್ಸ್ ಆನ್ ದ ರಿಮೂವಲ್ ಆಫ್ ದಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಈಗೊಂದು ಇದೊಂದು ಮೆಟೀರಿಯಲ್ ಐತಿ, ಈ ಮೆಟೀರಿಯಲ್ನ ಒಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನಾಗ ಇಟ್ಟಿರ್ತೀವಿ. ಸೊ ಈ ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ರಿಮೂವ್ ಮಾಡಿದಾಗ ಈ ಮ್ಯಾಗ್ನೆಟೈಸೇಷನ್ ಪ್ರಾಪರ್ಟೀಸ್ ತೋರಿಸ್ತಂದ್ರೆ ಅವಾಗ ಏನಂತಾರೆ? ಹಾರ್ಡ್ ಮೆಟೀರಿಯಲ್ಸ್, ಹಾರ್ಡ್ ಫೆರೋಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅಂತೇಳಿ. ಸೊ ಇದನ್ನು ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ರಿಮೂವ್ ಮಾಡಿದ ತಕ್ಷಣ ಇಟ್ ಶೋಸ್ ಇಟ್ ಬಿಹೇವ್ಸ್ ಆ್ಯಸ್ ಎ ಡಯಾಮ್ಯಾಗ್ನೆಟ್. ಅಂದ್ರೆ ಯಾವುದೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟೀಸ್ ತೋರಿಸೋದಿಲ್ಲ. ಅವಾಗ ಏನಂತೀವಿ? ಸಾಫ್ಟ್ ಫೆರೋಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so the hard ferromagnetics example alnico, nickel and cobalt. The soft ferromagnetic examples the soft iron. And the susceptibility has a large positive value. Already you got the idea. All the magnetic field lines are passes inside the material. So at that time the material becomes easily magnetized. So material easily magnetized atandra our susceptibility ಏನಾಗುತ್ತೆ positive value ಇರ್ತದೆ. And relative permeability is highly, it is also very high. It is more than 1. It is in the order of 10 raised to 3. And if the temperature rises, the susceptibility of ferromagnetic substance decreases. ಯಾವಾಗ ಟೆಂಪ್ರೇಚರ್ ರೈಸ್ ಆಗ್ತೈತೆ ನೋಡ್ರಿ ಆವಾಗ ದ ಸಸೆಪ್ಟಿಬಿಲಿಟಿ ಆಫ್ ಪೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಡಿಕ್ರೀಸ್ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಒಬೇಸ್ ದ ಕ್ಯೂರಿ ಲಾ ಆರ್ ಕ್ಯೂರಿ ಟೆಂಪ್ರೇಚರ್. ಸಸೆಪ್ಟಿಬಿಲಿಟಿ ಇಸ್ ಡೈರೆಕ್ಟ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದಿ ಟೆಂಪ್ರೇಚರ್ ಅಂಥೇಳಿ ಹೇಳ್ತೀವಿ. ಆ್ಯಂಡ್ ಇನ್ ದಿಸ್ ಪೆರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ದ ಈಚ್ ಮೆಟೀರಿಯಲ್ಸ್ ಹ್ಯಾವಿಂಗ್ ಈಚ್ ಡೊಮೇನ್ ಹ್ಯಾವಿಂಗ್ 10⁻11 atoms inside this domain. ಅಂದ್ರೆ ಗ್ರೂಪ್ ಆಫ್ ಅಟಮ್ಸ್ ದ ನಂಬರ್ ಆಫ್ ಅಟಮ್ಸ್ ಎಷ್ಟು ಇರ್ತಾವಪ್ಪ ಅಂದ್ರೆ ಒಂದು ಡೊಮೇನ್ದಾಗ 10⁻11. ಆ್ಯಂಡ್ ದೀಸ್ ಆರ್ ದಿ ಆಲ್ ಅಬೌಟ್ magnetic properties, and always you have to distinguish these all points, distinguish the diamagnetic, ferromagnetic and ferromagnetic materials. Okay, generally ಏನು ಫಸ್ಟ್ ಪಾಯಿಂಟ್ಸ್ ಎಲ್ಲ ಥರೊಳಗೆ ಏನು ತೊಗೊತೀವೋ ಜನರಲ್ ನಾರ್ಮಲಿ. So the materials in the diamagnetic materials, the material will be moved from stronger region to weaker region because it is diamagnetic material. And paramagnetic material, the material will be moved from weaker region to stronger region. Paramagnetic, it will be moved weaker to stronger. So on the bar magnetic external magnetic field ಇದ್ದಾಗ the field lines ಇಲ್ಲಿ ಏನಾಗ್ತಾವೆ ಎಕ್ಸ್ಪೆಲ್ ಆಗ್ತಾವೆ ಅಂದ್ರೆ ರಿಫೆಲ್ ಆಗ್ತಾವೆ. ಬಟ್ ಇದ್ರೊಳಗೆ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್, ಲೈಟ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್, ಇದ್ರೊಳಗೆ ಹೈಲಿ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್. ಸೊ ದ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಟ್ಟಾಗ ಸೊ ಏನು ಮೆಟೀರಿಯಲ್ನ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನಾಗ ಇಟ್ಟಾಗ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ದಾಗ ಇಟ್ ವಿಲ್ ಬಿ ಮೂವ್ ಫ್ರಾಮ್ ಸ್ಟ್ರಾಂಗರ್ ಟು ವೀಕರ್ ರೀಸನ್. ಆ್ಯಂಡ್ ಇನ್ ಬೋತ್ ರೀಸನ್ಸ್ ದ ಫೆರಾ ಆ್ಯಂಡ್ ಫೆರೋ the material will be moved from weaker region to stronger region. And magnetic dipole moment here is in the diamagnetic 0, and here is present, and here also present. And the relative susceptibility is where small and negative, here positive value, and here also susceptibility is positive. And the relative permeability here in the diamagnetic it is 0, in the ferromagnetic it will be slightly greater than 1, and it is very high. The relative permeability is very high. It is in the 10⁻⁴, 10⁻⁴. And this obeys paramagnetic materials obeys the Curie law. Ferromagnetic also obeys the Curie law, but in diamagnetic it does not obey Curie law. It shows the Messner effect. Okay, this is about the ferromagnetic materials. Okay, thank you.